there is a copper wire sitting on a table in front of you, and nothing about it seems remarkable. It is not glowing. It is not vibrating. It is cold to the touch. But the moment you connect that wire to a battery and send a current through it, something happens in the space around that wire that has no classical explanation. A nearby compass needle swings. A charged particle passing beside the wire curves in its path. Something reaches out through empty space and pushes. We have been calling that something magnetism for centuries, and we have been fundamentally wrong about what it is. Not wrong in the sense that the observations are incorrect. The compass needle does swing. The particle does curve. The measurements are precise and repeatable and form the foundation of every motor, every generator, every piece of electromagnetic technology ever built. But wrong in the deepest possible sense, the sense that matters most to a physicist. We have been wrong about what magnetism actually is. We have been treating it as a force in its own right, a fundamental player in the game of nature, standing alongside gravity and the nuclear forces as one of the primary architects of the physical world. And it turns out that this entire picture is an illusion, a beautiful, completely self-consistent illusion produced by the geometry of space-time itself. Magnetism does not exist as an independent force. What you experience when a magnet snaps to your refrigerator, what you see when iron filings arrange themselves into those elegant arcing patterns around a bar magnet, what you measure when a current-carrying wire deflects a charged beam, all of it is electricity, viewed from the wrong reference frame. Magnetism is what electricity looks like to a moving observer. And to understand why that is not a poetic metaphor but a precise mathematical statement, you have to go back to two of the most consequential moments in the history of physics. The first moment belongs to James Clerk Maxwell, working in the 1860s in Edinburgh, and what he did was nothing short of unifying two phenomena that scientists had spent decades treating as completely separate. Electricity, the force that governs the attraction and repulsion of charged objects, the thing that makes a comb pull tiny pieces of paper after you run it through your hair. And magnetism, the force that makes compass needles point north, that makes lodestones cling to iron ore, that sailors had been using for navigation for hundreds of years. These two forces had their own separate laws, their own separate experimental histories, their own separate mathematical frameworks. And Maxwell looked at all of those separate equations and found that they were not separate at all. He wrote them down together, 4 equations that described how electric fields and magnetic fields behave, how they change in time, how they respond to charges and currents. And when he looked at what those 4 equations implied mathematically, he found something that nobody was looking for. He found a wave that could propagate through empty space with no medium required, a self-sustaining oscillation in which a changing electric field creates a magnetic field, and that changing magnetic field creates a new electric field. And the two of them leapfrog forward through space indefinitely, carrying energy across the vacuum at a very specific speed. And that speed turned out to be 300 million meters per second, the speed of light. Maxwell had not set out to explain light. He had set out to unify electricity and magnetism. And he accidentally discovered that light is the result of that unification. Light is not something separate. Light is what you get when electric fields and magnetic fields dance together in precisely the way his equations describe. So Maxwell gave us the unification. Electricity and magnetism are not two different forces. They are two aspects of a single force, electromagnetism. But Maxwell did not explain why they are unified. He described the unification beautifully, mathematically, precisely. But the deeper question, the question of what it is about the structure of reality that makes these two things the same thing, that question had to wait for the second great moment. That moment belongs to Albert Einstein, and it came in 1905. Einstein was not trying to unify electricity and magnetism when he wrote his special theory of relativity. He was trying to resolve a different puzzle, a puzzle about the behavior of light itself. But what he produced in doing so was a geometric framework for understanding space and time that turned out to explain exactly why magnetism and electricity are the same thing, in a way that is so direct and so unavoidable that once you see it, it is impossible to unsee. Here is the core of what Einstein showed. Space and time are not fixed, absolute containers through which the universe moves. They are flexible, dynamic, and they respond to motion. Specifically, they respond to motion in a way that has a profound and counterintuitive consequence called length contraction. When an object moves relative to you, its length along the direction of motion, as measured in your reference frame, is shorter than its proper length, the length it has in its own rest frame. This is not an illusion in the sense of a trick of perspective. It is a real, measurable, geometric consequence of the way space-time works. The faster an object moves relative to you, the more contracted its length appears in your measurements. At speeds close to the speed of light, the contraction becomes dramatic. Now take that fact and bring it back to the copper wire. A copper wire is electrically neutral when no current flows through it. It contains positive charges, the protons sitting in the fixed lattice of copper atoms, and negative charges, the free electrons that can move through the metal. In equilibrium, the linear density of positive charges and the linear density of negative charges are equal. There is no net charge per unit length. The wire exerts no electric force on anything outside it. Now connect the battery. Electrons begin to flow. The wire still has the same number of positive charges and the same number of negative charges per unit length, measured in the lab frame where the wire is at rest. So, the wire is still electrically neutral in the lab frame. There is no electric force on a stationary test charge placed near the wire. But now bring a second charged particle into the picture, and crucially, let this particle be moving in the same direction as the electrons in the wire, and at nearly the same speed as those electrons. From the perspective of that moving particle, from the reference frame of the moving charge, the electrons in the wire are approximately at rest. The positive protons in the lattice, however, are now moving in the opposite direction at high speed, because in the frame of the moving charge, the wire itself is moving backward. And here is where length contraction enters with full force. The protons in the wire, which are moving relative to our test charge, are length contracted. Their spacing along the wire is compressed. So the linear density of positive charges, as measured in the frame of our moving test charge, is higher than the linear density of negative charges. The wire is not electrically neutral anymore, not from this reference frame. It appears to carry a net positive charge, and a net positive charge produces an electric field. And that electric field pushes on our moving test charge. What we measure in the lab frame as a magnetic force on a moving charge is, in the rest frame of that charge, simply an electrostatic force caused by the relativistic compression of charge density. Let that settle for a moment, because the implications are enormous. There is no magnetic force happening. There is only an electric force, and the question of whether it appears as electric or magnetic depends entirely on which reference frame you are observing from. The distinction between electricity and magnetism is not a distinction between two different things in nature. It is a distinction between two different ways of describing the same thing from different states of motion. Magnetism is the relativistic shadow of electricity. This is why Maxwell's equations contain magnetism. Not because magnetism is a separate force that happens to mix with electricity, but because Maxwell's equations are, in a deep sense, already relativistic. They were written down before Einstein formulated special relativity, but they already encoded the geometry of space-time. When Einstein developed his theory, one of the first and most beautiful confirmations was that Maxwell's equations are automatically consistent with special relativity without any modification. They do not need to be updated. They were already correct. Maxwell had accidentally written down a relativistic theory before anyone knew what relativity was, and this means something profound about the magnetic field. When you hold a permanent magnet in your hand, what you are holding is not an object that possesses some special magnetic essence. What you are holding is an object in which the spins of a large number of electrons are aligned in the same direction. Electron spin is itself a quantum mechanical phenomenon, a kind of intrinsic angular momentum that each electron carries. And aligned electron spins produce circulating currents at the quantum level, tiny loops of moving charge. Moving charges produce magnetic effects. which we now understand to mean that moving charges produce electric effects that appear magnetic from certain reference frames. A permanent magnet is therefore a macroscopic manifestation of the collective relativistic electric fields of trillions of quantum-scale moving charges, all pointing in the same direction. The iron in your magnet is not doing something separate from electricity. It is organized electricity viewed from the frame of the laboratory where those organized quantum currents are moving and therefore producing the geometric distortion in charge density that we call magnetism. Now follow this thread one step further because it leads somewhere extraordinary. Maxwell's equations do not just describe static magnetic fields and static electric fields. They describe what happens when these fields change dynamically. And when you have a charge that accelerates, when you have a current that varies in time, the changing electric field produces a changing magnetic field, and that changing magnetic field produces a new changing electric field, and this self-sustaining propagation moves outward through space. This is an electromagnetic wave, and an electromagnetic wave traveling through the vacuum at the speed of light is, in precise physical terms, light itself. So trace the logical chain from beginning to end. A moving electric charge, due to the geometry of space-time, produces what we measure as a magnetic field. A changing magnetic field, by Maxwell's equations, produces a changing electric field. A changing electric field produces a changing magnetic field. The two fields sustain each other, propagate through the vacuum, and constitute electromagnetic radiation. Light is not separate from magnetism and electricity. Light is what you get when the relativistic relationship between electricity and its own geometric shadow in spacetime is set into self-sustaining oscillation. This means that every time you see light, every photon that has ever struck your eye, you are seeing the consequence of the same length contraction physics that makes a current-carrying wire attract a moving charge. The light from a distant star is the same physics as the force that makes two parallel wires carrying current in the same direction attract each other. They are the same equation. They are the same geometry. They are the same underlying fact about how space and time are structured. And this has a consequence that cuts even deeper. You cannot have magnetism without the possibility of light. You cannot have light without the framework of special relativity. And you cannot have special relativity without the fact that space-time has a specific geometric structure, a structure in which the speed of light is the same in all inertial reference frames, a structure in which length contraction is real and unavoidable. If you were to change the rules of space-time geometry, if you were to make length contraction impossible, you would not just eliminate magnetism. You would eliminate light. You would eliminate electromagnetic radiation in all its forms. You would eliminate the mechanism by which energy propagates across the cosmos. This is what physicists mean when they talk about unification. Not simply the observation that two things tend to appear together, not a correlation discovered in data. Unification means identifying the deeper geometric truth from which both phenomena necessarily follow. Maxwell unified electricity and magnetism at the level of equations. Einstein explained why those equations had to be unified by showing that electricity and magnetism are the same force seen from different vantage points in space-time. And the field that carries both, the electromagnetic field, is the same field that sustains light. A bar magnet sitting on a table is, when you strip away the labels and the classical intuitions, a frozen configuration of the electromagnetic field. The field lines that arch from its north pole to its south pole are the same field that, when set into oscillation by an accelerating charge, becomes the visible light that illuminates the world, the infrared radiation that carries heat, the radio waves that carry information across continents. The geometry that allows a refrigerator magnet to hold a piece of paper to a metallic surface is precisely and exactly the geometry that allows the light from a star 4 light years away to travel through empty space and land on your eye. You cannot sever that connection. You cannot decide to live in a universe that has magnetism but not light, or light but not magnetism. They are not two features of the universe that happen to coexist. They are two expressions of a single underlying geometric reality, the structure of space-time itself, the fact that the laws of physics look the same in every inertial reference frame, and the consequent fact that moving charges see a length-contracted universe that produces forces we have, for historical reasons, been calling by two different names. When you understand that, when you genuinely absorb what special relativity is telling you about the nature of force and motion and the geometry of space and time, the world does not become less interesting, it becomes more so. Every interaction, every electromagnetic phenomenon, from the chemistry that holds your molecules together, to the light arriving from the edge of the observable universe, to the force that makes a compass needle swing, becomes part of a single story. A story written in the language of geometry, in the mathematics of space-time, in the equations that Maxwell found and Einstein explained. Not two forces, never two forces. One field, one geometry, one unified physical reality, expressing itself in every magnetic pull, in every pulse of light, in every electromagnetic interaction that has ever occurred anywhere in the universe.